Hi, welcome back. In this session, we'll be talking about queue. So, in the last couple sessions, we have talked about stack, one of the abstract data type. We also have seen how we can implement stack using array, okay, and also with the concept of structures and all. Okay. So today we will talk about another type of data structure which is called as queue. Like stack, okay, queue is also a list, right? So in the stack, we have seen that the entire insertion and deletion happens in only one end, which we call at the top of the stack. But in the queue, the insertion is happen at one end and the deletion happens in the other end. The end at which the insertion happens, okay, it is called as a front, or it is pointed by the front, okay, and the insertion which happens, it is the rear, I'm sorry, and the deletion where it happens, it's represented by front itself, okay. And so insertion is done at one end. You can see this is the end where rear we have, okay, and this is the end where the removal has been done, okay. Removal is done. So this is the queue which we have 12, 22, 31, 14, 16, 27 other elements, okay, and 12 is the front element of the queue, right? And this will be removed, okay. If any deletion will happen, so 12 will remove. After that, 22 will remove, and anything that we need to insert, it will happen after 27, which has been represented by rat. So queue is a list where insertion happen at one end, which is called as rear, and okay, and the deletion happen at one end, which is called as front. Sorry, and that removal of the element, it is called as dequeue, and the inserts of element is called as the enqueue, right? Let me again tell you, queue is nothing but the list where insertion happen at one pin, which we call it as the rear, and deletion happen in other end, which we call it as the front, okay. Insertion is called as enqueue and deletion is called as dequeue itself, okay. So let us understand the attributes, that is front and rear. As I was saying, front represent the element that we need to remove it, and rear represent at the end where we will going to insert an element. And there is one that we call as counter, where with the number of elements in the queue, if you want to know the number of elements in the queue, then it will be represented by the counter itself, and the max size gives you the capacity of the queue, right? Then let us understand the operation. As we have seen in the stack also, we have to see whether stack is empty. Right here, queue also is queue is empty. If it is empty, it will return true, and if it is not, it will return false. Is full, again we have to see whether stack queue is full, as we have done as the stack is full or not. We said then a stack overflow, okay, and underflow, like that we had that, right? Here is full, whether we want to see whether stack queue is full. So if queue is full, we say it is true. If it is full, it is true, and if it is not full, then it is false. And then we have the insertion element of it, of at the rear of the queue, which we call it as an queue, and deletion of element at the front of the queue, we call it as the dequeue. And if you want to print or display all the elements of data in the queue, then we have the display queue itself, right? So is empty talks about queue is empty or not. Is full, whether checking whether stack is full or not. Inserting an element at the rear end, and queue. Deletion of element at the front of the queue, dequeue. Display all elements is nothing but the display queue operation. An attribute front pointing to the element which you want to remove, right? Okay. Rear, where you want to insert the element, right? Counter, giving the number of elements in the queue, and the max size, that's about the capacity itself, right? So the model represent like this. If you have a queue called as queue, then n queue, x queue means we are inserting an element x into the queue at the rear end, okay. And if I write dequeue, we are saying that we are trying to remove an element from the front of the queue itself. So front pointing to the element which you want to we will be removing, and the rear where we want to insert an element itself, okay. So like stack, where we used to say the concept like LIFO, last in first out. In queue we call it as FIFO, first in first out, right? So typically, queue you have seen. Let us take an analogy itself, when you go and somewhere you want to buy a ticket itself, now you will be standing in a line itself, right? Okay, and once you want to join the line, you will always at the end of the line, which is right, and the person who will be at the front of the queue will get the ticket itself, right? So that itself is nothing but a queue, right? Anything that we want to remove will be at the one end, anything that we insert at the other end, which we call is that the rad itself, right? Okay, and the operation that we do for inserting an element, we call it as the enqueue, okay, right? Which insert an element in the rear of the queue, and if you want to remove the element from the queue, okay, and from the front, we call it as the dequeue itself, okay. Yes, so let us see an example, right? Initially, if you see rear and front both were maybe, you know, we can think something like that. Since we are implementing in the C itself, right? We can say the rear and front are all are -1, okay? Or typically in algorithm we said 0. Let us take -1, -1. Now, when you are inserting an element into the queue itself, okay, and now we see that we are rad is also -1, the front is also -1. Now the element has been inserted, now rad is pointing to 3, okay, but typically actually front here, okay, still is -1, but we have shown, because as we say that front always point to the first element of the queue itself, right? But when you do in an algorithm way, okay, we will increment the front, okay, and then we remove it. Yes, but here in order to show you, right, in order to show you, we are showing that front is pointing to the first element itself, okay. And then again, if we want to insert some six elements, so now rear is pointing to now is 6 here, okay. Now front will be, again it will be 3, because if you want to remove the element from, it will be nothing but the 3 itself, okay. Then we have 9, we're again inserting into the rear part, okay, right? So now let's see if this is a queue of size 3, this queue is full, okay. Now if you want to remove, right, if you want to remove, typically if you want to remove, if you say algorithm it front was in -1, okay, then we see whether what is a rad and front is equal to or not, and all this thing. Let in the algorithm we're going to explain it. Let us see here, just we removed it, 3 is been removed, now we have 6 and 9. Now the front will be pointing to 6, rear will be pointing to 9. Now if I remove 6, then both rear and well is equal to 9, and if I remove 9, now rear equal to -1 and front equal to -1. And again, if you want to do a dequeue operation, so we'll say nothing but skew is full, right? That is what we will going to say, right? So let us see the algorithm itself, okay. So let me tell you, front is -1 and rear is -1, here we consider that way, and is equal to 5, okay. So we have start this as 0, 1, 2, 3, 4. That is the reason why I've taken this as n-1. So if rad is equal to n-1, then it is the full. So initially rad is -1, so we have insert 29. So now rare becomes pointing to 29. Okay. Then you insert 64. Now rare becomes 64 itself. Right. Now say rare is only pointing to this. Okay. Right. So if you want to insert another element, still we have a space. Right. So that is not equal to this, okay, not full, right? So rare is rare +1, so rare moves here, and we have insert 75. So it's simple. So we have to see whether rare is equal to the size or not, okay. Rare is equal to size or not, since we are implementing in terms of 0, we are talking in C terms 0, 1, 2, 3, 4, like that. That's why n-1. Then q is full, right? Okay, otherwise we will increment rare, okay, and then we will insert the element into the queue. That's very simple. First, check whether rare is at the is rare is to the size, right? If rare is equal to the size itself, means stack is already been full, okay. And if it is not, then increment the rare, and then at that position of the rare you just insert the item, okay. So here n-1, because we are considering that it is implemented, the array is indexing, sorry, the queue indexing starting from 0, and it is 0, 1, 2, 3, not from 1. That is the reason why we have put n-1. Now in delete part, okay, let us understand that In order to delete, we have to check whether rear is equal to front or not. Okay, right? Rear is equal to front or not. Typically, you may see if you check rear is equal to -1 and rear is front is equal to -1. No, see, suppose I remove 29, I remove 64, I remove 75. Then what will happen? Now rear and front both are equal is pointing to 75 in this 75 location, right? So this is empty 75, but both rear is same. Now in this position, if you want to delete something, means nothing is there in the queue, right? So you have to check whether rear and front is equal or not. If it is not equal, okay, so typically front, even though I am pointing it to 29 front element error, actually it was -1. First, if you want to remove 29, front was -1, so -1 plus 1 will be 0. Now it will be 29, and then item q front, so 29 will be removed. Okay, then again, if you happen to remove, again I will check front equal to rear. No, front is not equal to rear. Okay, right? Because rear is here, now front is here itself. Okay, then again I increment front from the front will increment to this position, which is 64. Then q of 64 equal to item. Okay, the element is there. Okay, then it again come front is equal to rear. Yes, front is pointing to here. Okay, rear is pointing to here. Okay, now again front is incremented to 1, which is now point to 75, and you remove 75. Now in this position, now rear and front is equal and nothing is there in the queue. Now again if you come back and if you write front equal to rear, then queue becomes empty, right? So now if I want to delete 29, is so delete, just I want to do the delete operation, so it will simply move into that. Okay, right? So I represent this front pointing to 64 equally, but in the algorithm representation we increment the value of from, yeah, okay, yes, and then only we remove the element, because a typically front is in the this particular location. So make, in order to make you understand, we are putting it into that, because it's pointing to the what you say, the element, element that we want to remove it, right? So this is what the algorithm for delete. This is what the algorithm for what uh, this is for the insert, and this is for the delete, and we have seen delete operation. So an insert we call it enqueue, and delete we call it as dequeue itself, right? So let us understand some real life analogy. As I was telling you, you may be in the billing counter also, if you go to geomart, big bazaar and all these things, if you are doing some billing section also, you queue up in a line itself and all. In airport also, if you see a flight standing in a queue in order to get a runway to take it off, or sometimes the circle, the flights, what you say, circle in the air, air itself at the top of the airport, that is different. But you can visually, you can see, right, in the runway, it is there in the form of the queue itself. That some computer application, like in printer, if you try to print, okay, it will always be the queue. The first job will be in the one which will be printed first. Okay, like in scheduling algorithm for routers and all these things, so anything that will, it will be on the queue basis. Whoever comes first will get the opportunity. Also, if you see in process scheduling also, we have a concept called as first in first out, which is represented by queue itself. Whoever comes first will get the processors first, and all these things are there, right? The example, typical example of the queue itself. And this queue can be also implemented using an array. So in array, we know this is static in size, right? That array I've shown you the size itself, equal to n, okay, n minus 1 and all these things. And if you want to represent the by linked list, that is simply like, it is a completely dynamic. Okay, so never you will going to get itself full itself. So that's what queue itself is. Queue is nothing but FIFO, first in, first out. So we have operation which we call it as enqueue, we insert an element, okay, at the rear end, and dequeue, we want to delete an element from the front, right? And we have seen the operations of enqueue, and also we have seen the operation of dequeue, like insert, which call it insert and delete itself. Okay, so that's all about queue. Okay, so thank you so much. In the next slide, I will be giving you the implementation of queue using an array itself.